Good morning, 8th grade students. Today is August the 18th. And today our clear learning target is I can solve 1 and 2-step equations. So we have the parts of the equation. We have on the left side of the equation, we have two terms, one with a variable and the coefficient. And on the other side of the equator and the variable and the constant. And of course, this is also a constant, the 60 on the right side of the equation. To solve a one-step equation, we want to isolate the variable by using inverse or opposite operations. So in two-step equations, we use addition or subtraction to remove the constant. Another name for that constant that we think of is just whatever the number is without the variable. Secondly, we use multiplication or division to remove the coefficient. If dividing by a fraction, we can multiply by the reciprocal. Okay, one thing to think about, if I have a fraction like 3/4, its reciprocal is 4/3. So if I were dividing 3/4 by 3/4, remember from earlier years, I keep this term, I change division to multiplication, so I'm keeping 3/4. I change this to multiplication, and I do the reciprocal, or I flip the 3/4, which is 4/3. That will allow me to multiply straight across and have a product of 1. 3 times 4 is 12, 4 times 3 is 12, 12 divided by 12 is 1. So that's a handy tool when we're solving equations. Okay, in this first problem, we have 1x. We don't always see that 1 there, but it's 1 times x divided by 1.5 equals 16. Well, this is a one-step equation. So do I use addition or subtraction to remove the constant? No, because it's being divided. So I am going to come down here and I can write 1.5 divided by 1, because 1.5 divided by 1, or this in the numerator and this in the denominator, is still 1.5. And I'm going to multiply that by my 1 times x times 1.5 equals 16. And that 16, I'm going to divide by 1. That's still 16. I'm going to do this to illustrate my point. So because I was dividing by 1.5, I need to reverse that to isolate this variable. I multiplied this side by 1.5 divided by 1. What I do to one side, I want to make sure I do to the other side. So I'm going to multiply that side by 1.5. So on the left side, I have 1.5 times 1 times x, which is 1.5x in the numerator. The denominator is 1 times 1.5, also 1.5. Set equal to 16 times 1.5. 16 times 1.5. Let's refresh our multiplication. 5 times 6, 30. 5 times 1 plus 3 is 8. 0. 1 times 6 is 6. And 1 times 1 is 1. So add these together and I will have 240. Now, is that right? Remember, I've got a decimal here. So my decimal would normally be right here. I'm going to take it one place to the left. I've got to account for that decimal place. So that simplifies. 16 times 1.5 is 24. 24 divided by 1. Now, 1.5 divided by 1.5 is just 1. It divides into 1. 1 times x divided by 1 is x. 24 divided by 1 is 1. There's my solution to that equation. Number 2, I have 2 times n equals 42. Well, this is multiplication. How do I reverse multiplication? I need to remove the coefficient. So to undo or to reverse multiplication, I divide. Divide both sides by 12. 12 divided by 12 is 1, or 1 times n. We don't always write that 1, but it is there. 42 divided by 12. Well, let's check out our long division skills. 42 divided by 12. Put my decimal right there. How many times will 12 go into 42? 3 times. 3 times 12, 36. Put 0 there. If I take 36 from 42, I have 6. Bring down that 0. 12 goes into 60 5 times. 5 times 12 is 60. I have none left over. So my answer, 1n, or n is equal to 3.5, is my answer. So that means if I took 12 times 3.5, I would get 42. All right, number 3 is one that I really want to focus on because we have 6/7 times e equals 12. So, this fraction is multiplied by the variable. Okay, so I can divide by 6/7. In fact, that's the way I'm going to show you guys. So in essence, multiplying by the reciprocal. So 6/7 times e divided by 6/7 equals 12 divided by 6/7. Remember those compound fractions from 7th grade? They're still with us. Well, any number, fraction, whole number, decimal, divided by itself, 6/7 divided by 6/7 is equal to 1. So that simplifies out to 1. So I have 1 times e divided by 1, which is e. Then I have 12. If I want to write that as 12 divided by 1, that's divided by 6/7. Okay. Remember this keep, change, flip. So I have 12, change division to multiplication, and do the reciprocal of 6/7, which is 7/6. Couple ways to look at this. I can multiply 12 times 7, that is 84, and I can divide 84 by 6. Might have to do long division. 6 goes into 84 once. I have 2 left over. Bring down the 4. 6 goes into 24 4 times. Then I have nothing left over. So e is equal to 14. Now, some of you may remember or have seen others say, let's look right here. I see that I have 12. I see that I have a numerator with 12 times 7, and I have a denominator with 6. So I could think of this 12 divided by 6. Well, or 12 is divisible by 6. It's equal to 2. 6 is divisible by 6. It's equal to 1. So then I would have 2 times 7, which is 14. So that's another way to simplify that with fractions. Moving on. Number 4, I would just change 3.5 to 3.5. It's equal to 10. This is a one-step equation. I don't multiply or divide here. I'm just reversing this addition. So that is the additive inverse. So I'm subtracting 3.5 on both sides. Boy, I better get a decimal with that 10. So on the left side, I bring down this G. I notice that positive 3.5 and negative 3.5 zero out. There's zero. There's nothing. I'm done with that. So once again, I'm subtracting 3.5 from both sides because I've got to keep that equation balanced. So if I take 3.5 away from 10, I have 6.5. G is equal to 6.5. In this one, I am doing the additive inverse. I'm reversing this subtraction right here. So add 4.25 to both sides. Let's put our decimals there. Okay, on this side, I have a T. Notice again, I'm adding 4.25 to negative 4.25. That zeroes out. Now I have negative 4 plus 4.25. So my integer rules tell me that, or I could commute the 4.25, it's positive, minus 4.00, then I would easily see that I have 0.25. So T is equal to 0.25. And finally here, another one step, add 6 to both sides. Be careful, it's 6.0. I have a decimal here. I might want to go ahead and put that decimal there. This will zero out, but I will still have my 1m. And my variable m is equal to 9.6. I could substitute 9.6 in for m and subtract 6, and I would have 3.6. Coming down here, these are called algebra tiles, and these two algebra tiles here are x's. In fact, they're negative x's. How many are there? There's 1 and 2 of them. So my equation on the left side would be negative 2x is equal to, my right side, I have 1, 2, 3, 4, 5, 6 negative 1s. So negative 6. That's how I transfer or translate these algebra tiles model to an equation. So now I'm ready to do multiplicative inverse. Got to undo that multiplication with division. And I have x is equal to positive 3. Moving along through here, I'll just work through these problems, check to make sure that your answers are correct. Number 8, 14 plus 9m equals negative 13. Subtract 14 from both sides. This becomes 0. I still have 9m. I'm isolating that variable with the additive inverse is equal to negative 27. I do my multiplicative inverse, which is dividing not by 3, but by 9. 9 divided by 9 is 1m. Negative 27 divided by 9 is negative 3. Number 9. I love number 9 because there's a couple different ways we can interpret number 9. Notice on the left, I only have a constant, and on the right, I have a term with a variable. So I have the term with a variable and a term that's a constant. Notice that's a 1n divided by 2. And I really like for students to think of it as 1/2 times n minus 6. So one way to think about it. Your parents, tutor, or siblings might teach you another way, and that's perfectly fine. So, do I add 12 to this side? If I do, that zeroes out. And then I would have 0 equals 1/2 n plus 6. Well, let's just go ahead and get the constant to this side. That will give me -6 equals 1/2 times n. This is where I want to, I'm solving for that variable n. I want to divide by the coefficient of 1/2. Divide. So then I have -6 divided by 1/2. On the left side, on the right side, I have 1/2 times n divided by 1/2. Leaves me with n. Now I love this. A lot of times students think -6 divided by 1/2 is -3, but it's not. -6 divided by 1/2. Can make that -6 divided by 1. So that becomes -6 divided by 1 times 2 over 1. So n is really going to equal -12. N equals -12. Another way I like to think about this, when you're here with this -6 equals 1/2 times n and you're dividing by 1/2, if you think about, forget the negative, think about if you have 6 sticks and you divide them in half, okay? Probably going to do a terrible job, and I'm going to try to divide these in half. How many halves do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore, 6 divided by half is equal to 12. Don't forget your negative there. Those are lots of fun. Number 10. Isolating the variable. If I've got a constant on the left and a constant on the right, I want to get those together. 1/2 v. Still left, I bring that down. -16 plus 16 zeroes out. Be careful here, I've got -4 plus 16. That is a positive 12. Now I'm dividing by 1/2. 1/2 times b divided by 1/2 is equal to 12 divided by 1/2. So 12 divided by 1/2, you might remember from this particular problem, 12 divided by into halves will be equal to 12 is equal to 24. B is equal to 24. Okay. On this one, we have 4 times w plus 15. Take 15 away from each side. Balance that out. This zeroes out. Bring down 4 times w. -13 minus 15, or -13 plus -15. We're combining two negative numbers. We're getting further from 0. We're at -28. Now I'm reversing multiplication. 4 divided by 4 is 1w. -28 divided by 4 is -7. Coming along here, we have d divided by 1.6 plus 31 equals 40. Let's subtract 31, doing that additive inverse, getting rid of addition with subtraction. I still have d divided by 1.6. This zeroes out, and then I have 40 minus 31, which is 9. Now notice I have d divided by 1.6. Reversing division means I want to multiply. So I'm going to multiply both sides by 1.6. Helps to think of that with the denominator of 1. Okay, if I multiply this side by 1.6, I also want to multiply this side by 1.6 divided by 1. Left side, two numbers divided by each other, same number divided by itself is equal to 1. So I have a 1d, which I write as just d. Then I have 9 times 1.6. 9 times 1.6. 4. I have 14. 1440. 1440 can't be right. I have 2 decimal places, so I have to account for those. So D is equal to 14.4 or 40. Number 13. Subtract 19 from both sides. Additive inverse with subtraction. 2/3 times B is equal to 16. Then I want to divide. Well, here, instead of dividing by 2/3, let's go back up here and think about if dividing by a fraction multiplied by the reciprocal. So I could, this is another way to look at it, I could make that 16 divided by 1. So I'm going to multiply by the reciprocal. The reciprocal of 2/3 is 3/2. Notice I still have the B there. What I do to one side, I do to the other. Take a look at this. 3 times 2 is 6. 2 times 3 is 6. Still have that B there. On the right side, I have 16 times 3 divided by 1 times 2. 16 times 3 is 48. Divided by 1 times 2. 6 divided by 6 will leave me with that 1B. 48 divided by 2 is 24. So B is equal to 24. I could have also looked here and I could have noticed that 16 is divisible by 2. So 16 divided by 2 is 8. 2 divided by 2 is 1. So that gives my numerator 8 times 3, which is 24, and my denominator 1 times 1, which is 1. Still, B is equal to 24. Number 14. We have a good old word problem. We've got Lucy on a beach trip. She gets a bike from Wheels by the Waves, where they rent bikes for $12 plus $3 per hour. We know that she spent $30. How many hours did she rent the bike? So we want to know how many hours. I'm going to circle that. We see some numbers. Let's think about the meaning of those numbers. She had to pay a one-time fee of $12. That's just one time. One time fee. Plus $3 every hour per hour. We know that she spent a total of $30. So how many hours did she rent the bike? Well, my equation could look something like this. 12 plus 3 times H. $3 for every 1 hour is equal to a total of $30. One way to write the equation, one way to work the problem. Remember, we're 8th grade students going into algebra, so we need to be able to translate word problems into an equation. When I solve this equation, additive inverse gives me something like $3 per hour times the number of hours is equal to 18. Then divide by 3, I have hours equals 6. So she rented the bike for 6 hours. Skip number 15. Look at number 16. I do love these algebra tile problems. We have 3 negative x's, 3 negative x's, and 3 negative 1's. We see this balance right there. That's a fulcrum. It's keeping it balanced. So there's my equal sign. The right side, I have 1, 2, 3, 4, 5, 6 negative ones. So there's my equation to translate from an algebra tile model to an equation. Use those inverse operations to reverse subtraction. I'm going to add 3, still have negative 3x. This zeroes out, is equal to negative 3. Divide by negative 3, and x is equal to positive 1. I'm going to continue working through these problems silently. Make sure that you know how to do them.